Hello guys and welcome. So in today's video, we're going to explore how to perform advanced SQL queries using window functions and partitioning to analyze data more effectively. So by the end, we'll break down a query that ranks universities by project value, calculates running totals, and identifies the highest contributing scientists, all while keeping detailed row information intact. So we built this query one step at a time, starting with basic aggregation and then moving into window functions. So now let's get started. So these are the two tables that I'll be using. So I'll be using scientist table, which is the parent table, and it contains information about the scientists, and research project, which is a child table, and it contains information about the research project conducted by the scientists. So these are the two tables that I'll be using to build my query. So let's start simple by using group by to calculate the total project value per university. So this is the most basic aggregation where we group the data by university and sum up the project value. So here what it will look like when I run it. So the group by class groups the rows by university, and sum here calculates the total project value for each university. So this is a basic aggregation that reduces our data to a summary by university. So at this point, we are using aggregation, which means we do lose some details. For example, if we wanted to rank universities by total project value, group by alone wouldn't allow us to keep that detailed information. So that's where window functions come in. Now, let's add window function to our query. So I've added a row number here as our part of our query. So window functions basically allows us to perform calculations across rows while still keeping every row in the result set. So this is really useful when we want to rank, calculate running totals, or look at specific windows of data. So I've added row number here, which will give each university a rank, as you can see here, based on the total project value. So here, row number assigns a rank to each university based on the total project value, starting from 1 for the highest value and so on. Notice how we use overclass with order by to specify how the ranking should be calculated. So this keeps all rows intact, unlike group by here, which reduces the result set. Now, let's take it a step further by adding entile. So we've added row number. So now I'm gonna add entile to our query. So basically, entile divides the variable according to the value that you assign to. So I've assigned number 4 here to my entile. Basically, it divides the universities into quartiles based on their total project value. So this is really useful for understanding the distribution of your data. So from here, I can see which university is the top 25% and which university is top 50% and so on. So I've also want to look into dense rank. So I'll replace entile with dense rank. So dense rank is basically another ranking function, but it handles ties differently from row number. So if two universities have the same project value, as you can see, Glasgow and College Cork have the same total project value, they get the same rank, but the next rank continues without skipping any number. So it gets, for Cambridge, gets number 2. The difference is that row number here, it basically assigns number 1, 2, 3 and so on. Also, there's another function called rank. It's a bit confusing. A lot of people get confused by this because rank and dense rank kind of sound similar. However, it's a bit different. As you can see, I can show you now here actually. So you can see Glasgow and College Cork have the same value here, and it will assign the same number of rank. However, it will not go to the next number. It will skip a number and goes to number 3 for the next one. So you can see Cambridge get number 3 for rank, and for the dense rank, Cambridge get number 2. So basically almost similar, but not really. So now basically to kind of summarize it, entile divides the data into specified buckets like quartiles to categorize universities based on their project value. So dense rank ranks without gaps in case of ties, making it useful when you want to show consecutive ranks without skipping numbers. But rank basically ranks with gaps in case of ties. So you still want to show consecutive ranks but it skips a number. And difference from rows is that it will show in according to basically from 1, 2, 3, 4, 5 and so on. And now let's move on. Let's basically add partition by. So this is basically, it's not a part of my main query, but I do want to show you how it works anyway. So this partition by is basically allows us to perform calculations within specific groups while keeping all rows intact. So partition by is different from group by. which aggregates rows together. So by using partition by here, the data is still displayed in its original form, but calculations like ranking restarts for each partition. So for example, I've partitioned by using town, so we can rank universities within each town. So here, partition by town here, make sure that the ranking starts over for each town. So this is where partition by shines, basically. It allows us to perform calculations within groups while still keeping all the data rows visible. So unlike group by, partition by does reduce the result set, as you can see here. Yeah, so you can see it kind of collapses the rows here compared to using partition by. Now let's move on to building our query. So we've added a row number, we've added and tiles, we've talked a bit about partition by and dense rank and so on. So now let's add rows to define a window of rows for the calculation. So for example, we can calculate a running total of project values across all universities. So this syntax of rows between preceding and current rows here tells SQL to calculate the total from the beginning of the partition, which is unbounded to the current row. So rows controls the range of rows that a window function considers. So unbounded preceding means the window starts at the first row, and current row means the window ends at the current row. So for example, running total project here adds up all the project value from the start of the university data to the current row. So this gives us basically a cumulative sum. You can also use rows between one preceding and current rows to only consider the previous row and the current one. Now, I want to move on to basically building more of our query by adding lag. So we've added the rows preceding and such, and so now let's run lag. So the lag is actually really one of the most powerful window functions because it allows us to access data from the previous rows. It's really good for comparing values across rows, such as showing a university's project value compared to the previous one. So lag gives us the value from the previous rows in the specified window. So in this case, it compares the project value of the current university with the previous one. And notice that the College Cork is blank. It's because it's the first one in the data. So it's the first row and it has nothing to compare it to. So basically, if you're at the first, you have nothing to compare it to before, right? So that's what happened to any of the first row of the data set. So it will show in as blank. And LED is basically the opposite of lag. It's another function, but it compares to the future row, basically. That's what the difference between lag and LED is. Now let's put it all together. Let's run it all. Notice I've also added a few more aggregate functions. So I've added max, sum, more counts, basically to show the nationality count, scientist count in each university, as well as which degree contributes the most to each university in terms of project value. So this query does everything. It calculates the total project value, ranks the universities, tracks running totals, and finds the highest qualification of the scientists contributing most to the project value. So we've used partition by to calculate totals within each university, lag to compare values to the previous row, and I've showed you how tile and dense rank work for basically ranking. So now you guys learn how to combine window functions, partitioning, and aggregation to create advanced SQL queries. So with that, you guys can try to experiment with rankings like using dense rank or tile, running totals, and moving averages using rows. So maybe you guys next time you guys can try to add use rank instead for different ranking styles, or you guys can try to use lead instead of lag to look at future row values, or experiment rows between options like preceding, current rows, and following for even more precise windowing. So I hope you guys find this useful. So yeah, that's all my queries for today, my video for today. So thank you so much.